Okay, this is lesson 10.3 for those of you who missed class today for your Disney trip. And if you need further review of this, you can of course watch it and rewind and pause and fast forward and try problems and whatever. So use this to prepare for your quiz and test next week. Operations with radical expressions. We're going to jump right to your vocab. For starters, like radicals are radicals that have the same radicand. So the example that's on the screen says, that's not right, says 3 square roots of 5 and 7 square roots of 5. This one, you can see that the 5, that's the radicand, is the same. So if I wanted to, I could add these together. 3 square roots of 5 and 5 square roots of 5 makes 8 square roots of 8. That's not right. 10 square roots of 5. Right? 3 plus 7 makes 10. Same, I could subtract them, and I would get 3 minus 7 is negative 4 square roots of 5. So just like terms where you have, for instance, 4x plus 3x, those are like terms. I could combine them because they have the same variable factors. So if you just imagine this square root of 5 and this square root of 5 as variables, they both have the same one. So we can combine them, we can add them, we can subtract them. However, your next vocab word is unlike radicals. So unlike radicals would be like the ones on the screen or on the PowerPoint, 4 square roots of 3 and negative 2 square roots of 2. Notice this 3 and this 2 are not the same, so those would be unlike. So I could not add these. If I tried to, the issue would be, well, this is square root of 3, this is square root of 2. That wouldn't work. Same thing, you could not subtract these because they're unlike. However, just as a side note, I could multiply them, which we've already learned about. 4 times negative 2 would make negative 8. 3 times 2 would make the square root of 6. So that would work, but you just can't add or subtract unlike radicals. The last vocab word is conjugates. Conjugates are the sum and difference of two terms. So if you imagine 2 plus 3, we know, of course, that makes 5. The conjugate of that would be 2 minus 3. And the thing that you need to keep in mind is conjugates. Notice the 2 and 3 don't change places between these. The only thing that changes is the plus changes to minus. So conjugates is, if it was plus, now it's minus. If it was minus, now it's plus. It does not apply to multiplication or division. It's just addition or subtraction. And we're going to use those in the last problem of the lesson. Okay, and there's an example of conjugates when it comes to square roots or radicals. So the square root of 7 plus the square root of 3, and its conjugate would be the square root of 7 minus the square root of 3. Again, nothing changes in the order of the two radicals. The only thing that changes is the addition and subtraction. All right, let's try a problem and show you how this is pretty simple stuff. Letter A. Letter A says 6 square roots of 11 plus 9 square roots of 11. Again, they are like radicals because they both have the square root of 11. The radicands are the same. So 6 plus 9 would make 15 square roots of 11. And that's it. The 6 plus the 9 makes the 15. Letter B, the square root of 3 minus 5 square roots of 3. This one, again, they're like radicals. And then this implied 1 here, 1 minus 5 would make negative 4 square roots of 3. C, 7 square roots of 2 minus 8 square roots of 2. 7 minus 8 would make negative 1 square root of 2, which would just be negative square root of 2. And D, 5 square roots of 5 plus 2 square roots of 5. These combine to make 7 square roots of 5. So again, like radicals, you can just add or subtract them depending on what the problem gives you. Problem 2 is a little different because in problem 2, you don't have like radicals. You have what are called, as we saw in the vocab, unlike radicals. So in that first example, 5 square roots of 3 minus the square root of 12. This is the square root of 3, this is square root of 12. They're not the same radicand, so they're unlike. You can't just go ahead and subtract them. However, as the problem says, you can simplify so that you can subtract them. So this 12, we can leave this 5 square roots of 3 alone, but this 12 we can make minus the square root of 4 times the square root of 3, just like you've been doing in the previous lesson. So the square root of this 4 becomes 2, and now you have like radicals. 5 square roots of 3 minus 2 square roots of 3, which you can do is 3 square roots of 3. Again, so you can simplify in order to combine like radicals. So letter A and B, why don't you take an opportunity to try these real quick based on what I just showed you. Just pause the video and try it out. And now we're going to look at it. Letter A, 4 square roots of 7 plus 2 square roots of 28. The 7 can't be simplified, but the 28 can. So 4 square roots of 7 plus 2 square roots of 4 times the square root of 7. And now we can simplify that. 4 square roots of 7 plus the square root of 4 is 2 times 2 makes that plus 4 square roots of 7. And now 4 and 4 make 8 square roots of 7. On letter B, notice there's actually 2 things we can simplify in this one. So 5 square roots of 32 minus 4 square roots of 18. Neither of these have a square root, so we need to simplify them. This one would be 5 times the square root of 16 times the square root of 2 minus 4 times the square root of 9 times the square root of 2. The square root of the square root of 16 is 4 times 5 makes that 20 square roots of 2 minus the square root of 9 is 3 times 4 is 12 square roots of 2. And now you finish. 20 minus 12 makes 8 square roots of 2. So again, sometimes you have unlike radicals, but you can actually simplify them so that they will become like radicals, and then you can add or subtract them. Problem 3. Sometimes you have to multiply radicals. And I'll read this for you. We'll look at this and see what it means. It says, when simplifying a product like this, so the square root of 10 times all of this, you can use the distributive property. So you would multiply the square root of 10 times the square root of 6 and times the 3. And then it says if both facts in the product have 2 terms, like this, both of these parentheses have 2 pieces, this and this, and then this and this. You can actually use FOIL to do the problem. So we're going to take a look at both of them, make sure you see how this works. So the first one is the square root of 10 times the square root of 6 plus 3. You can just use the distributive property. So remember, whenever there's a value outside of the parentheses, you can distribute it. So this times this. The square root of 10 times the square root of 6 makes the square root of 60. And then the square root of 10 times 3 is plus 3 square roots of 10. Then the square root of 60 can be simplified. And so now you go back to doing what you know to do. 60 can be broken down into the square root of 4 times the square root of 15. And then the square root of 4 is 2, so 2 square roots of 15 plus 3 square roots of 10. And then you can't simplify anything else, so this would actually be your answer. The second example is a little bit different, and there's 2 ways you can go about solving it. I'm going to attempt to do both on this paper. So the square root of 6 minus 2 square roots of 3 times the square root of 6 plus the square root of 3. Just as you did in chapter 8, I believe, we did FOIL. You can do this as a FOIL, so you can do first, outer, inner, last, or you can use the distributive property. So I'm going to show you both. This is FOIL, and then I'm going to show you distributive. And you can really do whatever you want to. You can do either method. So for FOIL, first you're going to do the first pieces. So the square root of 6 times the square root of 6 is the square root of 36. Then outer, square root of 6 times the square root of 3, positive square root of 18. Inner, this negative 2 square roots of 3 times the square root of 6 makes negative 2 square roots of 18. And last, negative 2 square roots of 3 times the square root of 3 makes negative 2 square roots of 9. And now, as you probably noticed, you can actually simplify this. So the square root of 36 is 6. Right here, these square roots of 18 are like radicals. So 1 square root of 18 minus 2 square roots of 18 will make negative 1 square root of 18. And then right here, the square root of 9 is 3 times this negative 2 makes negative 6. And then you have a 6 minus a 6. So the 6's are actually gone, and you're left with the negative square root of 18, which can then be broken down. Negative square root of 9 times the square root of 2, and then your answer is negative 3 square roots of 2. So, a lot of stuff going on, but as long as you keep to your method, keep following the steps, you should be able to get to your answer. The other way is the distributive property. So for distributive property, a reminder, you're going to take the first piece of the first parentheses, so square root of 6, and you're going to multiply it by the whole second one. So this would be the square root of 6 plus the square root of 3. Then minus the second piece of the first one times all of the second parentheses, square root of 6 plus the square root of 3. And now you do your distribution. Right here we have the square root of 36. Here we have plus the square root of 18. Here we have negative 2 square roots of 18. And then here we have negative 2 square roots of 9. And then you'll notice, let me zoom out, you'll notice that this here is the same thing we got when we FOILed. And so now all of this ends up simplifying down to the same answer we got when we FOILed. So it's all about which way you want to do it. You can use FOIL or you can use the distributive property. So pause the video, try some examples, and then I'm going to show you what those answers are real quickly. So I'm going to show you the answers to these real quick. I'm not going to go through and explain every little detail just for the sake of time. So letter A, square root of 2 times square root of 6 plus 5, square root of 12 plus 5 square roots of 2. Break that down, square root of 4 times the square root of 3. This becomes 2 square roots of 3 plus 5 square roots of 2. Can't do anything else to that. 2 square roots of 3 plus 5 square roots of 2. Letter B, square root of 11 minus 2 squared. This one's a little bit tricky at first, but really it just means take the whole thing and multiply it by itself. That's what squaring it means. And now you either do your FOIL or your distribution. Square root of 121 minus 2 square roots of 11 minus 2 square roots of 11 plus 4. This becomes 11 minus 4 square roots of 11 plus 4. 11 plus 4 makes 15 minus 4 square roots of 11. Can't do anything else to that. Okay, so that's letter B. Let's finish that and do C. Okay, again, FOIL or distribution. First one is 4 square roots of 18. Outer would be plus 3 square roots of 36. Inner would be negative 8 square roots of 9. And last would be negative 6 square roots of 18. Simplify anything you can. So 4 times the square root of 9 times the square root of 2. Oh, actually, 4 square roots of 18 and negative 6 square roots of 18 can combine because they're like radicals. So 4 minus 6 makes negative 2 square roots of 18. And then simplify anything you can. The square root of 36 is 6 times 3 is 18. The square root of 9 is 3 times negative 8 makes negative 24. These can combine, so 18 minus 24 is negative 6. This can simplify, so negative 2 times the square root of 9 times the square root of 2. Square root of 9 is 3 times negative 2 is negative 6. Square roots of 2 minus 6. I can't do anything else. That's my answer. Okay, we have one more problem, and we're all very glad about that because we're done. So, problem 4, rationalizing a denominator using conjugates. So, letter A, 10 over the square root of 7 minus the square root of 2. Now, I told you in your vocab that there's something called conjugates, and conjugates means we're going to take an expression like 2 plus 3, and we're going to change it to 2 minus 3. So all that changes is this sign, this operation in the center. So what that means for this is I cannot simplify the square root of 7, and I cannot simplify the square root of 2, which means I need to rationalize the denominator, which we learned in 10.2. And what you learned is we're going to multiply the top and the bottom by this stuff in the bottom. With this problem, though, you're going to multiply the top and the bottom by the conjugate of the bottom. So instead of minus, we're going to do the square root of 7 plus the square root of 2 over the square root of 7 plus the square root of 2. And now, when you look at this, you're initially maybe weirded out or intimidated. You don't know what's going on. But picture it like this. Put parentheses around the top and around these in the bottom. And now, all of a sudden, you have a distribution problem on top, and you have a FOIL problem on bottom. So that's what you do. So to get this, 10 times the square root of 7 makes 10 square roots of 7, and 10 times the square root of 2 plus 10 square roots of 2. So that's the top. Now, the bottom, we need to FOIL it. So I'm going to do all that right here, and then I'm going to throw it down into the denominator when we're done. So FOILing this, square root of 7 times the square root of 7 makes the square root of 49. The square root of 7 times the square root of 2 would be plus the square root of 14. Inner, negative square root of 2 times the square root of 7 would be negative square root of 14. And last, negative square root of 2 times square root of 2 would be negative square root of 4. And now we need to simplify this. Notice the middle pieces can combine. So 1 square root of 7 minus 1 square root of, 1 square root of 14 minus the square root of 14. These actually are going to go away. And you're going to be left with the square root of 49 is 7. minus the square root of 4, which is 2. And you're going to have 7 minus 2, which is 5. And that goes in the denominator. And then your last step is, if you can simplify anything in this fraction, you need to. So 10 divided by 5 is 2 square roots of 7. This 10 divided by 5 would be plus 2 square roots of 2. You can't do anything else to this, so you're done. Now, the last thing you need to know is the problem began, you can even see on the slide right here, the problem began with the square root of 7 minus the square root of 2 on bottom. But now notice the bottom becomes 7 minus 2. So all that happened is the square root, the radical symbols are gone. And we're left with 7 minus 2, which is what the radicands were. And then we just subtract them and get our answer. What you need to know is every single time you do one of these problems, all that's going to happen to the denominator is the square root symbols are going to be gone, right here, 7 minus 2. But also know it's always going to come out as minus in the bottom. So even on letter B, if you look at letter B, there's a plus sign in the bottom. Even when I do this problem, what's going to happen is the square root symbols are going to be gone, and I'm going to be left with 10 minus 5 in the bottom. So you know immediately the denominator of letter B will be 5, because 10 minus 5 is 5. So I'm going to show you that real quick as our last problem. So on letter B, the negative 3 over square root of 10 plus the square root of 5. Again, multiply the top and the bottom by the conjugate of the bottom, which is minus. And now do your distribution. So on top, that becomes negative 3 square roots of 10. And then negative 3 times negative square root of 5 is positive 3 square roots of 5. And then on bottom, we need to do our FOIL. So 10 times 10 is the square root of 100. Outer would be square root of 10 times the negative square root of 5. So that would be negative square root of 50. Inner, positive square root of 50. And last, negative square root of 25. Now the key here too to remember is these two middle values will always end up canceling out. That's how this works. They will always cancel out and you'll be left with what was on the front and on the end. So the square root of 100 is 10 minus, right here, minus the square root of 25 is 5. And so just as I told you, it's going to become 10 minus 5, and the answer to that goes underneath here. So looking at this, negative 3 won't divide by 5, 3 won't divide by 5. You can't break down 10 or 5 anymore in the radicands, so, or as the radicands. So this becomes your final answer. So if you need help, make sure you use the question help on Math Excel. Also, remember that the Math Excel for this is due Monday, May 14th. That's this next Monday. And then you have a quiz on this lesson on Tuesday, May 15th. And then your Chapter 10 test is Wednesday, May 16th. So if you missed or you just need additional help, you can watch this video again, see me for more help, use your Math Excel for more help, and make sure that you're ready to go.